All right, so yesterday we were factoring to solve equations. So when you're doing that, your first step is to move everything to one side, then you can factor. Okay, so you should have moved the 12x over. And then was there anything special that you guys noticed about this? A perfect square trinomial, absolutely. Okay, so when you're doing the perfect square trinomials, recognize that you have a perfect square first and last, so it's going to be 3x, and then the square root of 4 is 2. Now, how do you know whether it's plus or minus? How do you know if it's plus or minus? Yep, it's always the same as the middle number, okay? So the way that you should write it is 3x minus 2 squared equals 0. Then you can take the square root of both sides, yeah? And then normally when you take the square root, you do plus or minus. You don't have to worry about it for this one because it is 0, and you can't have a positive or negative 0. Then you're going to add 2 to both sides, divide by 3, then you have x equals 2/3. All right, so anytime you have equations, notice that these are different than the other ones that we did because you have an equal sign. You have to set them equal to 0 and you have to solve. If they don't have an equal sign, you are not going to be solving them, okay? And some of your homework, you I think there were only like a couple people that solved this not by factoring. So when you're factoring, you just want to move over. You're going to subtract 9 from both sides, and then you can factor. Now, this is a special pattern too. This is the difference of two squares. Okay, now the other step you have to be careful of, and some of you, I wrote you a note on this. You have to make sure you are using the zero product property. So that means when you're using the zero product property, you are allowed to say that 4x plus 3 equals 0 or 4x minus 3 equals 0. I need to see that step. That's a key step. And then I said, as long as you're showing me that step, if you want to do these two-step equations and show me the final answer, that's fine. So if you want to jump from here to here, I'm fine with that. If you want to write out the minus 3 and then the divided by 4, I'm fine by that as well. Okay? So this one, you would add 3 and then divide by 4. So this would be your final answer. X equals negative 3/4 or x equals positive 3/4. Would it matter which one you put first? No. Nope. Does not matter. Okay, but again, the step I need to see is where you're setting both of them equal to 0. Okay, and that's something that we talked about in our notes yesterday as well. All right, so we are going to be using some of the things that we've been talking about this week in today's lesson. And today's lesson is going to be about completing the square. Now, is that a phrase we have heard before? Completing the square? Okay, so some of us yes, some of us no. All right, so we are going to focus today on solving quadratic equations by completing the square and using the square root property to solve quadratic equations. This last one, the quadratic equations in vertex form, I actually made a day 2 for this and put that on there just because I didn't want to overwhelm you with too much stuff today, okay? All right, so the first thing we're going to talk about is the square root property. So the square root property says if you have x squared equal to some value, which they call n, so if x squared is equal to n, then what you're going to do is you are going to take the square root of each side And when you do that, you end up with plus or minus the square root of n. So when you are using the square root property, because some of these are going to say, oh, you have to use your square root property, understand that that means you are going to have to take the square root of both sides. That's how you're going to have to solve it. Also, you are going to need to make sure you have the plus or minus, because if you're taking the square root, you got to have your plus or minus on there. And then the last thing we have to remember is we have to simplify our radicals where possible. Now, when we say simplify radicals, what are we looking for in the radicals? Yes. So when you're simplifying radicals, you have to make sure you're looking for those perfect squares. Okay, that's what simplifying the radicals means. Okay, so for examples 1 through 3, we're going to solve each equation using the square root property. Now, some of these equations are going to look like what we did yesterday, but we're doing something else. So I know some of you like to work ahead. Please do the first one with me. Okay, so we have x squared plus 8x plus 16 equals 49. If we were doing this like we did yesterday, we would move this over and then we would try to factor it. But today we're using the square root property, which means we're going to have to factor perfect square trinomials. So today we are going to be factoring the perfect square trinomials first. So you may recognize that 16 is a perfect square and x squared is a perfect square. So if you were to factor that, you could start with x and x. What multiplies to 16 but adds to 8? 4. And then are they going to be positive or negative? Positive. It should always match this symbol here. Now remember, the way that we write that is we want to write that as x plus 4 squared. And now we can use the square root property. So when we do this in the future, we're going to go straight from this step to this step, because we've been doing this pattern enough now where we can just go straight to this, okay? And then you're going to take the square root of both sides. Okay, when you take the square root, don't forget your plus or minus. The square root undoes the power of 2. And then what is your square root of 49? 7. Okay, now I'm going to show you a certain way to write this, and that's because it's going to help you for our future ones. So if you can write it out with me. We're going to subtract 4 from both sides, and I want you to think of it as this. This is a negative 4 plus or minus 7. Okay, so the reason why I want you to think of it like that is that's how we're going to write out our future answers. This one is a little different because you can actually add negative 4 plus 7, and you can do negative 4 minus 7 and get an answer, right? Negative 4, oh, sorry. I do that sometimes. In my mind, I'm thinking what it's going to be. Okay, so negative 4 plus 7 is going to be 3, and then negative 4 minus 7, negative 11. I gave it away, spoiler alert. Okay, and then the way you're going to write your final answer is x equals 3 or negative 11. Okay, or you could say x equals 3 or x equals negative 11. All right, so then based on that, I want you to start part B. So we have x squared minus 12x plus 36 equals 28. So I want you to start it just like we did on the other one. All right, so then when you guys are trying to figure out what this is going to be as the factor, if you want to set it up as just this squared, you can. Okay, so x squared, we know that's going to be x. So you're asking yourself, what multiplies to 36 but adds to negative 12? Negative 6. Now, when you're doing that, remember, if this is negative, this is going to be negative. Okay, you're really just always taking the square root of that and then applying that sign. Okay, and then from there, we're going to take the square root. Okay, so we have plus or minus the square root of 28. When you are simplifying that, it's not a perfect square, it's not a whole number, but you have to find the perfect square in there. For ones like 28, I do expect you to know what the perfect square is, just because that's one of your multiplication facts. But you could also do your factor tree, right? You could break it down, 2 and 14, 2 and 7, you can do that, okay? So when you are checking for perfect squares, do you guys know like the first perfect square you look for? 4. And is 4 going to 28? How many times? 7. It's okay. Okay, so if you rewrite this, the square root of 28 is 4 times 7. You can break this up into 2 of them so that you can simplify. So on one of our quizzes, I noticed some people were still having trouble with this. So the way that you know which one comes out is the one that's the perfect square. The square root of 4 is what? 2. It's a whole number, so that's why that can leave the square root. But the square root of 7 is not a whole number, so that has to stay inside. Okay? So it's going to be 2 root 7. Okay, and then your last step is going to be to add 6 to both sides. So you're going to have 6 plus or minus 2 root 7. Okay, and you can write that as 2 answers if you want to. This does mean 6 plus 2 root 7 and 6 minus 2 root 7. You can also leave it like this. So now can you see why I wrote it like that for this one? You're always going to put this in front so you can have your plus or minus here in the middle. Okay, that's the form for it. All right, so then I want you guys to try part C. 25x squared minus 10x plus 1 equals 75. So I put your perfect squares up here on the board too. So when you get to the point for where you're simplifying, you can see a 4 goes in there, then 9, then 16, 25, 36. You want help there? All right, so when you're doing this first step, this is a perfect square trinomial. So the square root of 25 is 5. So it's 5x because you have the x squared with it. Square root of 1, 1. Okay, and then z, what sign are we going to put here in y? Yep, and y. Yep, that's the middle one. So it's always going to match the middle, right? Okay, and then from there, you can take your square root. All right, and then Zurish, did you find a perfect square that goes into 75? Great, so 25 times 3. Awesome. Okay, so 25 goes into 75 3 times, so I'm going to rewrite that as plus or minus 5 root 3. Okay, and now I can do the plus 1, and everything we've done up to this point has been similar to our other examples. We're going to extend it one step further. Okay, so remember before when we had to write things in A plus BI form and in slope-intercept form, right? So they have to be like this because we have to simplify. It's the same thing here. So when you are dividing, when you divide on this side, you're really dividing each term by 5. And you want to think of them separately because sometimes only one of them is going to simplify. So you have 1/5 plus or minus, and then what happens here? Yep, the 5s are going to cancel, so you're just going to be left with the square root of 3. You can't go any further because you cannot add a number and a radical together. Okay? So you have to leave your final answer like this. Okay, so that's also why we did not go any further here. Why didn't I add 6 plus 2 and make it like 8 root 7 and 4 root 7?
Because that's 2 times the square root of 7. And if you're adding or subtracting 6.
So in your order of operations, what has to come first? Multiplying or adding and subtracting? Multiplying. So that's why you can't do it. Okay, so you can't add before you multiply. Okay? All right, so I want you to do part D. Something familiar should pop up. Let's see how you do. All right, so in this one you had to get a negative square root. So what has to be in play when you have a negative square root? I. Had to yell at one of my other classes today because they didn't remember. We just took our quiz on that, so we can't forget that. Okay? If we have eye problems, I'm going to have to send you to the optometrist. Okay, so here's your plus or minus 7i. Okay, not negative 7 here. Okay, this means the square root of negative 1 times the square root of 49. That's what your I value is. Okay, so plus or minus 7i. Last step, subtract 8. That's going to go in front. So just like you would not add a number and like 2x, you wouldn't add a number and something with I in it. Okay, those are not like terms. So this should be your final answer. Okay, so good job if you remember that imaginary number. Okay, and then the next thing that we're going to do is again going to deal with perfect squares. So the directions tell us to find the value of c that makes each trinomial a perfect square. So we are now going to create the perfect square trinomials. Okay, and then it says, then write the trinomial as the square of a binomial. And that sounds pretty cool and sophisticated. Maybe we aren't sure what that means. So let's break it down. A binomial is just what? Two terms. The square of a binomial, it's what we have here. Isn't x plus 8 a binomial? This is a binomial squared. 5x minus 1 squared, that's a binomial squared. So it's really just your factored form. So when they're saying write the square of your binomial, you're writing this in factored form. So that is something that we have done before. Okay? All right, so you are basically filling in what the perfect square trinomial should be. Anytime you factor a perfect square trinomial, you have the same exact value twice. So you have x and x. So what's going to add to negative 14? Negative 7 and negative 7. Okay, so then how can I find c from that? Yeah, you just multiply them together. Negative 7 times negative 7 is 49. Okay, it'd be really nice if we just had a formula for that, right? We do. Let's see if we can come up with it. So let's think about this relationship, right? How do negative 7 and negative 14 relate to each other? Okay, so one way I can write that, remember that this value is called b. So you can just do b divided by 2. Isn't that how you can find half of it? And then how did we get to 49? How did we go from negative 7 to 49? You square it, yep. So you take half of b and then you square it. That's what we're going to use from now on, okay? So let's show it with this. So negative 14 divided by 2 squared is negative 7 squared, and that's going to be 49. So you can just use this formula from now on. Now we do have to write out what the binomial is. And so see how you have the x minus 7 times x minus 7? It's just x minus 7 squared. Okay, and again, you can always factor it. If you know that c is 49, right, it factors into x minus 7 squared. So this is exactly what we were doing our first step above, okay? All right, so I want you to do b. And all of those you have to do without a calculator. So all of them you have to do without a calculator. All right, so let's see how our formula went. So if you did b over 2, you did 6 over 2 squared. So 3 squared is 9, so that's your b value. Okay, and then when you factored, right, what times what is 9? 3. Okay, now, you may have noticed this, you may have not. See how this ended up being a 3? Look what's here. A 3. Did that happen with this one? Yeah. Yeah, -7. Okay. Yeah. So for C, this is a little different because it is odd. So when it's an odd number, when you're doing this without a calculator, you are not going to mess around with those decimals. You're going to leave this as a fraction. Okay, leave as a fraction. Okay, so when you are squaring a fraction, all you have to do is square the numerator and square the denominator. Okay, so -7 squared is 49, 2 squared is 4. That's going to be your value of C. Okay, so 49/4. Okay, so don't write that as a decimal, leave it as a fraction. Now, based on what we did there, now when you are writing your value, remember how we said, oh, this is 3, this is 3, this is -7, this is -7. So what can I put here? Yeah, -7 over 2. See how that's going to be easier than trying to do with the decimals? All right, so everything that we did on this side is going to help us with completing the square. It seems like a few of you have heard of it before, but some of you are looking at me like you've never ever heard it, so I'm going to teach it like you've never done it before, okay? So when you're solving by completing the square, you must have the coefficient of x squared be 1. Okay, so the coefficient of x squared must be 1. Do you guys remember what variable we associate with the coefficient? Yes, a. So a equals 1. Okay, if you don't have if a is not 1, you need to divide. If not, then you divide both sides by the a value. Then you divide both sides by the a value. So if the a value was 2, you divide both sides by 2. If it was -3, you divide everything by -3. Now notice in the directions, again, they are asking you to solve this in a very specific way. They say solve each equation by completing the square. Okay, so you have to make sure that you are following that direction. Okay, so we're going to do this together. We're going to start just by writing out our original equation, which is x squared equals 12x minus 20. Okay, so that's what's given to me in part A, and we need some room here. So step 1, it says get all of your variable terms on one side. Okay, so variable terms are the terms with x in them. So you should have ax squared plus bx on one side and the constant term c on the other side. So that means we are going to move 12x over. Make sure that when you're moving something over, that you do the opposite, because I've seen people make small mistakes like that, and then it throws the whole thing off. We don't want that. Okay, and then it says, is the coefficient 1? You have to make sure that your a value is 1. Is your a value 1 here? Yeah. Okay, so good. You may proceed. Now, the next thing says fill in the blank spaces with, but you have to put in your blank spaces. So when you were learning how to solve equations, your teachers probably always said to you, oh, whatever you do to one side, you have to do to the other. So we are going to put in a blank space on the left side of the equation and the right side. Okay, so we have x squared minus 12x plus blank equals negative 20 plus blank. Okay, now if I cover up this side here, this looks exactly like what we did on the previous page, except instead of a blank, what did it say? It said plus C. It's the same exact thing. You're going to have to find C. Do you guys remember what we used to find C? Yeah, b over 2 squared. So you are going to fill in the blank spaces with b over 2 squared. Okay, so to complete the square, we're going to fill those in. So if you do negative 12 over 2, you get negative 6. And I like to write it like this, the negative 6 squared. I'll show you why in a second. Okay, and then on this side, I like to actually square it. So negative 6 squared is 36. So I'm going to write 36 here. Okay, you have the option to either write this as 36 or you can write it as negative 6 squared. So what you're trying to do next is write this in factored form. So if you have this and you are writing that in factored form, that is exactly what you were doing on the front page. If you're factoring this, it's a perfect square trinomial. So this has to be x. What can you multiply by itself to get 36? 6. And then it has to be minus because the middle is negative. Are you guys with me on that? Okay, so the reason why I like to write it like this is because I don't even like to think about factoring again. I know if this is negative 6 squared, it's just going to drop down. So I just like to do that. You don't have to do it like that. If you want to put the plus 36 there, you can. We put the 36 here, though, because you can add negative 20 plus 36. What's that going to make? 16. And then from there, you're just going to solve. Okay, from here, it's exactly like what we did in our first example. Okay, so I want you to square root both sides. Yep, anytime you take the square root, you're going to want your plus or minus. Okay, so anytime you take the square root, you got to put that plus or minus in front. We know that the square root of 16 is 4. And then we're adding 6 to both sides. So remember, with ones like this, you can actually find your answer. You have 6 plus 4 and 6 minus 4. Okay, so write your final answer with your or in between, and then you can start part B. Again, anytime it's odd, you want to leave it as a fraction for part B. Okay, so x equals 10 or 2 should be your final answer for part A. All right, now for part B, I want you to get all of your variable terms on one side. That's your first step. And then all of your numerical terms on the other side. And while you're moving over the negative 9x, you can also add over the 2. You can do that in one step. Okay, plus blank equals 2 plus blank. Again, just double check that your a value is 1. Okay, so if your a value is 1, you know that you can complete your square. Okay? Now, it's negative 9, so if you cut that in half, it's a fraction.